Hello students. In this video we're going to invoke a couple rules of differentiation in order to determine the value of the derivative of this function f at x equals 1. Now you don't know what f is. We're just assuming that it is differentiable. That means you could take the derivative of this function f and the derivative will exist. Okay, it's not going to blow up at the point 1. All right, so let's go about how we would determine what f prime of 1 is, given f of 1 is equal to minus 1. Now, x is assumed to be the independent variable, so we'll be differentiating with respect to x. Also, after we differentiate, we will use the fact that here x is equal to 1, so we'll evaluate f at x equals 1, and we'll plug in minus 1, and then we'll solve for f prime of 1. So that's our strategy. Here we go. So I'll differentiate both sides with respect to x. Then I will use the linearity of the differential operator here. So that just means I'm going to distribute the d dx, so to speak. Take the derivative of this constant, minus 2. So the derivative of a constant, remember, is 0. Then I will use the product rule on this first term. So I have f of x cubed, that's left alone. I'll take the derivative of x, plus x left alone times the derivative of f of x cubed, plus, okay, so this whole expansion here on the left, these two terms are the result of differentiating this term here using the product rule. Now I'll differentiate this term. Again, I'm going to have to use the product rule because this is x times f of x. So I will take the derivative of x with f of x left alone plus x left alone times the derivative of f with respect to x. And then the 0 just follows along on the right-hand side. Now, I'll simplify. So I have f of x cubed, dx is simply 1, plus x. Now here I'm using the chain rule. So this is one of the other rules we'll use. So remember when you use the chain rule, you take the derivative of these so-called outside functions. So that's going to be 3, and then we subtract 1 from the exponent, and then we leave the inside, this outside function evaluated at f of x. So we leave the inside alone, multiplied by the derivative of the inside, that's f prime of x. So here we just invoke the chain rule. So that takes care of these two terms. Now we'll look at these two terms from the product rule of this derivative. The derivative of x with respect to x is simply 1, plus, and then the derivative of f of x is f prime of x. Now we'll clean this up a little bit, and that's the result of cleaning that up. So I just multiplied by the 1s, and that's all there is to that. That's pretty simple. Now I'm going to rewrite that last line there up at the top, and I'm going to plug in 1, x equals 1. So remember, if you have f of 1, that means that x is equal to 1. And then we're going to get an output. So x is our input variable, that's our independent variable, and the output will be minus 1. So I'll plug in 1 everywhere I see an x. And then f of 1 is minus 1. So f of 1 is minus 1. We don't know what f prime of 1 is. That's what we're trying to find out. F of 1 is minus 1. 1 times f prime of 1 is simply f prime of 1. And we don't know what f prime of 1 is. That's the unknown. Now we'll just simplify using the laws of exponents. So minus 1 cubed is minus 1. Minus 1 squared is 1. So 3 times 1 is 3. F prime left alone plus minus 1 plus f prime of 1 is equal to 0. Now we'll just add the minus 1's together to get a minus 2. 3 f prime of 1 plus 1 f prime of 1 is 4 f prime of 1, still equal to 0. And now we just do some algebra. We add 2 to both sides, and then we divide by 4, and 2/4 is 1/2. So f prime is equal to 1/2. That is it. So in summary, we use the linearity of differentiation to distribute the differential operator. Then we invoke the product rule for these two terms. We used the chain rule on this term. We simplified. Then we plugged in the given input, x is 1. Then we evaluated that f of 1 to get the output, minus 1. And then we simplified arithmetically, and then we solved for f prime of 1, which is the unknown. Find f prime of 1. All right. That's all there is to solving this problem. Good luck.